this is Pauline for AP Statistics. In this video, I'm going to go over the Chapter 1 review sheet, and we're going to go over problems 6 through 10. Jennifer, a huge fan of chocolates and their many varieties, often purchase pre-packaged boxes of mixed chocolates. And this word mix is really important. So it's not all the same type of chocolate, it's mixed batches. The chocolates in these boxes come in 4 different varieties: white, milk, dark, and extra dark. Over time, she collected chocolate on the frequency of the different varieties that are placed in these boxes. Which of these conclusions can be made given this data? So we look at the different frequencies, but remember what they did is they looked at the customer purchases, but each box is a variety. Okay? Customers prefer chocolate. Well, even though there's a higher frequency of milk chocolate, it wasn't that the customers were only buying boxes of milk chocolate, they were buying varieties. So since the boxes were prepackaged, maybe the company just loaded it up with milk chocolate. So you can't really tell from this data if customers prefer milk chocolate. Same reason for the dark chocolate. Just because you have a lower frequency, maybe it's more expensive to have dark chocolate, so there are fewer pieces of dark chocolate in these boxes. Stores sell more milk chocolate than any other kind of chocolate. That's the same problem. These boxes are mixed. So if it was a homogeneous box and only milk chocolate, then you could make that determination, but not based on the mixed boxes. Choice D, the pre-packaged boxes contain twice as many milk chocolate as white chocolate. That you can say. Remember, they took all these purchase boxes, they counted the number of chocolates, so we know. So if you take 47, 47 is twice as many compared to the white chocolate or any of the other chocolates. So that most likely is our answer. Without more information, we cannot tell anything about the chocolate varieties. So since the best choice would be choice D, because we do know within each box the type of chocolate. So we know there's twice as many, more than twice as many milk chocolate than any other in these prepackaged boxes. So let me just try to highlight that. Okay. The prices in thousands of dollars of 35 used cars at a certain car dealership are shown below. Which of the following best describes the shape of the distribution of used car prices at this dealership? And so you're given the data, but the data is represented in a I'm going to get a line, in a frequency table. And so we want to get a sense of what the shape of the distribution is. And you can do this a variety of different ways, but I think the easiest is to just really sketch it out by hand. So I'm going to make a number line. You could do it in the calculator, but I think this is actually faster. So 7, 8. And it really doesn't take, this was on an AP exam. It should be really more evenly distributed. Hopefully I didn't skip any numbers. And so we have 4 dots at 7, 6 dots at 8, 7 dots at 9, 6 dots at 10, 4 dots at 11, Oh, I'm a little crooked here. 2 dots at 12, 2 dots at 13, 2 dots at 14, 1 dot at 15, and 1 dot at 16. And we can see that it's skewed right. Another way of saying skewed to the right is positively skewed. Typically, we say skewed to the right, but occasionally in some older textbooks, you'll see positively skewed. For left, another term for it would be negative skewed. So you're given a histogram of waiting times, like in a dental office, and it's really important to see that we have a sample size of 175 patients, and they want you to find which of the following could be a possible median of the waiting times in minutes. Now, we're not given the raw data, so how can you tell from that? Well, you're going to estimate because you have a histogram, and on the side, what you should notice is the number of patients or frequencies. So we know that the median is the position. We can determine the position of the median, and we can do that by taking 175, the sample size, and divide it by 2. And when you do that, you get 87.5. So when you have an odd number of data, you're going to get this 0.5 and you're going to round up. This tells me that the position of the median, this was also an AP question, is in the 88th position. Position of is the 88th term. I'm going to say 80th term. So how can you tell? You're going to have to estimate. They want to find the interval, like they want to give you an approximate amount. So let's look at this frequency. The frequency of the first bar is 80. Well, that's certainly below 88. And here, between 5 and 10, looks around 50. So 80 plus 50, the two together, is 130. So somewhere in this interval, and let me highlight it let me highlight it blue. Somewhere in this interval is going to be the 88th term. And so it can't be $2.50. This is looking good, the 7.25. These are too high. So the answer is choice B. And I'm just going to be consistent and highlight that in yellow. Mr. Eicher gave a test to his wonderful AP Stats students. I have better students, all 52 of them. So you have to pay attention to like this detail. So I know that I have a sample size of 52. Remember, lowercase n represents sample size. Which of the following statements are true? Okay, the test scores are centered in the 80s. So in this case, this distribution is skewed left. And when you have a distribution that's skewed, you should use the median for the center. And we can figure out the position of the median by taking the sample size and dividing it by 2, and you get 26. So we know that the median is between the 26th and 27th term. So we count from the lowest, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So the average of those two, we don't know exactly what those values are, but it definitely, the median looks like it's in the 80s. So that's a true statement. Okay, the test scores have low outliers. Well, we see most of the scores are fairly close together, in the 70, 80 range. And we have these 3 lowest test scores, okay? We don't know for sure that they're outliers, but you have a pretty good sense that they're far away from the others. You could actually enter this in the calculator, but that would be a waste of the time. So this, I would say, is a true statement. The test scores are skewed right. It's just the opposite. They're skewed left. So the answer would be choice 1 and 2, and that's choice D. Number 10. When testing water for chemical impurities, results are often reported as BDL, below detection limit. And this becomes important. So if you had trouble with this problem, you can't ignore that BDL. The following are the measurements of the amount of lead in a series of water samples taken from any sitter households in parts per million, ppm. 5, 7, 12 BDL, 10, 8 BDL, and 20 and 6. Remember, BDL is almost zero. Not zero, but pretty close. Which of the following statements could be true? Okay. So, notice that they're talking about the mean and the median. We really can't determine the exact value of the mean because we don't have what BDL stands for. Can we determine the median? Yes. But how do you determine the median? You have to order the data from least to greatest. So we're going to do that. Well, BDL is something, but it's very, very small. So we have 2 BDLs, and then we have a 5, 6, we have a 7, then comes 8, then comes 10, 12, and 20. I think I have them all. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9. So the median, if you have 9 divided by 2 is 4.5. The median is in the 5th position. So we're going to count from the lowest. 1, 2, 3, 4, 5. That's the median. So the median is 7. So we can't determine the mean because we don't have the values of the BDL, but we can figure out the median, and that's why the answer to this problem is choice C. Okay, I'm actually going to do 11 and 12, though I initially was going to stop every 5, just because I think these are short. A distribution has a shape that's strongly skewed left. So I'm going to make a distribution skewed left. Which of the following is true about this distribution? Okay. So when I think of a distribution skewed left, I think of someone who has like all high 90 grades, and then they took a test when they were good and sick, and they shouldn't have taken it, and they got a 70, which was totally out of character. How does it affect their score? Their mean would drop, but their median, which is based on position, would not. So I like thinking of that situation when I have something skewed left because it helps me remember what's going on. The mode is always going to be the most, the highest point, the most frequent. The median is going to be in the middle. And in this case, the mean is going to be to the left. So the mean is going to be less than the median, which is choice C. The standard deviation of 16 people's weights in pounds is computed to be 5.4. The variance of these measures, well, what is the variance? The variance is the square of the standard deviation, and this is the sample variance, so Sx squared. So you would take 16 squared and get, oh, that's 16. That's the sample size. Sorry about that. 5.4 squared. And that would give you 29.16. So that's choice B. Just so you know, if they gave you the variance, so let's say the variance of something, it's not part of the problem, but I just want to make sure people understood it. If they said the variance was 36 and they wanted you to find the standard deviation, you would take the square root of it. I just added this as a side note. It has nothing to do with this problem. So if you're saying, where did she get that 36 from? It's just to make sure people understand the relationship between variance and standard deviation. Hopefully this video is helpful.